Good morning. I'm jslosson, the old math guy down the hall, 53 years and counting. Today we're going to finish up measuring C, in which we get the kids measuring to 16ths. And in addition to that, I'm going to add in measuring D, which is really ruler magic. We're going to learn to do some centering, dealing with broken rulers, bisecting some angles, checking for square, and a few things like that. So a pretty good lesson, very practical outside the classroom. Let's get started. I do want to remind you that you want to add tick marks on the sheet so that kids can easily draw their line and makes it easy for you to grade. You can walk around the room very quickly, see if they do the line the right length. And my policy is when your assignment is totally complete and totally correct, you can go dig into your phone or your Chromebook, and I'll help other people in the room. So just a reminder. And because measuring C is only 3 pages long, I added a page of review, little reducing, simplifying fractions by factors of 2 and place value. They should know that by now, but we never hurts to review. We'll be checking that out deep into second semester. Let's start with a concept that tradesmen call burn an inch. If you need a really accurate measurement and you have a wonky tape measure with a bad tip or a ruler that's kind of messed up, a lot of times guys will start at 1 and then measure an extra inch. And that's just far more accurate, especially if you have a ruler that doesn't start with 0. On this particular question, we're just asking them to find the middle of the line. They measure 5, then they go to 2.5, which is of course 2 8/16. But what if your line is just too long for your ruler? We want to find the center. Oh, this is more than 6 inches. So here's an idea. Just lay the ruler, put 0 on one end, and that looks like about 4, so we make a line there. Then we go down to the other end, and we put 4 on the end of the line, and we come back and we make a tick mark at 0. And then we can measure that little line, which is 1/2 inch, and there you go. We have the center line right there, no problem, sliding ruler. On this assignment, I do ask them to find the center of the long side of the paper and the center of the short side of the paper. Let's just suppose that you would like to divide this rectangle into 2 equal pieces, and that's going to be kind of a pain because it's, let's see, 1.5 plus 2/16, 1 5/8, 1/2 of 1 5/8 is 1/2 plus 5/16, or you could just put 0 of your ruler on the top line and 2 on the bottom line, and then you could make a tick mark at 1 inch. And voila, 2 equal spaces. On the lower box, we want 3 equal spaces. And rather than use inches, it's just a lot easier if we use centimeters. This one comes out very nicely at 0 and 6. We make 2 marks, 1 at 4, 1 at 2. That gives us 3 equal spaces. I wanted to double check my work, so I went down and did it all again. And that came out at 2 and 4. And I have 3 spaces, evenly divided, nice parallel lines. Finding the center of a square or a rhombus is just a corner-to-corner thing. They don't need to draw the whole line. Just get your construction lines in there, and that's easy peasy. Next, we're going to do a rectangle and a parallelogram, and this is how carpenters verify that the deck is square to your house. So we measure from corner to corner, and we measure from corner to corner, and if it's the same, it's square. Now, purposely, we made a parallelogram. You could get fooled if you had built a symmetrical trapezoid, but nobody's that far off. They've got a building square. Which brings us to some parallel lines. Let me move the paper. In order to do this lab, you're going to have some way to draw right angles. Ideally, it would be a drafting triangle, and I can't find any that are affordable. I used to be able to buy them in packs of 20 for $1 a piece, but now they're like $5, $6 each, and that's not affordable. So what I did instead, I went to Lidl's rectangles of chipboard. It's thick enough to do the job. I got a whole pack down at the print shop. Their cutter is very square, so they can cut 3x4 rectangles, and you can lay those against the ruler and get a pretty predictable 90-degree angle. So just a tip, if you've got a box full of triangles somewhere in the storeroom at your school, great. If you don't, that's a cheap way to get some right angle squares. So to get some parallel lines, all we have to do is lay our square parallel to the line, and then put our ruler down nice and tight and hold it, and then we can move our square and get all the parallel lines we need. I just drew one. It would be nice if you had thicker stuff, but this was all they had at the print shop for chipboard. A little bit thicker would make this a little easier. And if you've got them working as partners, one of them can hold the ruler down while the other one slides the square. If you wanted to bisect an angle, you could go get your compass and construct it. Or because you've got a ruler with a nice calibrated straight edge, what I did here is I made a mark at 2, and I made another mark at 2, and then I could have just measured the line, but I'm kind of lazy. So I just made a line, and then I used the other side of the ruler, which I've already verified as parallel, and I made another line, and then I just found the center of the resulting trapezoid. One of the things you want to show the kids is their construction lines should be very light. And then all I needed to do was go from the center of the trapezoid to the vertex of the angle, and I bisected it nicely. Now, sometimes that doesn't work out so well, especially when you have an acute angle. So in that case, I think I measured 35 millimeters, 35 and 35, yes. And I connected them and then measured, and let's see, what did it come out to be? It's almost 5.5, 5.5, so I just found the center right there. And I marked that, and I have the bisector. So pretty easy, no need to go get a compass and do a lot of construction. When you're out in the field, you don't have time to do that. All right, let's use our square cards and go ahead and find the center of a circle. All we need is a chord, and since you can decide, I just went ahead and put 0 there and 2 there and put a little mark at 1. And then I did the same thing with that chord, try to get them perpendicular. And since I didn't have triangles enough for the class, I used these square pieces of paper we talked about a moment ago. And I lay that on there so it's square with the line. Make a little mark. Come over here to the bisector of the other line and do the same thing. And there's the center of my circle. You'd be surprised how often you have to actually find the center of the circle. So we did the same thing there. 4 centimeters turned out to be the right number. Center of the circle, voila. Oops, almost forgot. If you want a copy of this lab, just watch till the end of the video and after the last credits, and I will put up each page for 4 or 5 seconds, and you can grab a screenshot. If you want a nice, clean PDF, email me, jim@prealgebra.net, and I will ship off your own copy. I would like to personally thank you for watching these videos. I can't do all of the project and assignments in what I call AGA Math Lab. You can go to the website and kind of check that out. But mostly, I want to thank you for what you do every day with kids that are behind and kids that sometimes have difficult behaviors. Not everybody's willing to do the important job you do. And as always, I want to remind you, these materials are not the magic. You and your ability to relate to kids and to help them get on with their lives, that's the magic. Thank you for doing that.